Hi everybody. Today's lesson is on reference angles. So, I know you're dying to know, what is a reference angle? Well, it's the smallest angle that the terminal side of a given angle makes with the x-axis. Okay, so some of these words are really important. The smallest angle that the terminal side of a given angle makes with the x-axis. Okay, we need to know that these are very important so we know exactly where the reference angle is. Other really important pieces are that it's always positive. The reference angle is always positive, and it's always less than 90 degrees or less than pi over 2 radians. So it's a small angle. And then, even more importantly, why do we use it? Well, we evaluate trig functions of angles based on their reference angles because coterminal angles have the same trig function values. So like if I asked you for the sine of 495 degrees, you'd be like, well, that number's bigger than 360. I don't like it, so I'm going to find a coterminal angle by subtracting 360. And I know that's the same as the sine of 135, but that's still not a fun angle to work with. We only really look at the ones less than 90, so these are all the same. And that's really the reason why we do reference angles, because the only one we would need to know is this 45, and then we can figure out infinite amounts of trig functions. So they're really important. Okay, so let's first talk about what a reference angle looks like. So the reference angle is the smallest angle made with the terminal side and the x-axis, and it's the smallest angle. We know that there are two, but it has to be small. So here the green is the given angle and the red is the reference angle. So in quadrant 1, they're the same. In quadrant 2, when I move, I'm looking at my terminal side, but it's the smallest angle made with the terminal side and the x-axis. In any angle in the second quadrant, that's where the reference angle will be. We move to the third quadrant. We're going a little past 180 here, right? 240. My reference angle is the difference between 243 and 180, because I need to know how much further I traveled. And then in the quadrant 4, I went all the way around between 270 and 360. And my reference angle is the distance between the terminal side, really, and the x-axis. So it's always positive. Okay, it was really the value that would get me to complete the circle. So if you think about it in terms of a circle and distance, it's a little bit easier. But sometimes we have negative angles, right? So I'm going to make this angle negative. Oh, well, that's not working. Well, hopefully I can get that working and we can show you in class. Either way, it's the same thing. It's just that our angle goes in the negative direction, but still with your quadrant, your reference angle stays in the same spot. So if I want to sketch the angle in standard position, find my reference angle, I need to start with my x and y axis, and I like to label them on every problem. So I'm in degrees, and I'm going in the positive direction, so 0, 90, 180, 270, and 360. So I like to do this so I know exactly where my angle is supposed to go. I know that 140 is between 90 and 180, so I start at 0, my initial side, and my terminal side is going to be somewhere between 90 and 180. So here is my given angle. But I'm really looking for my reference angle, right? That's what's important here. So that's from my terminal side to the x-axis. I need to know what degree measure that is. And I like to think about this like, okay, I'm going here and I'm almost at 180, right? I'm almost at the x-axis. I need to know how much further I have to travel to get there. So if I traveled 140 and I need to get to 180, how many degrees is that? Well, I know you're thinking it's 40, and that is my reference angle. So let's skip to number 3. So I'm going to do the degree ones and then the radian ones. So number 3, I'm still in degrees, and I still need to sketch. So So, but now I'm going in the negative direction. So should my labels. So this is going to now be negative 90, right? Negative 90, negative 180, negative 270, and negative 360. Because this time I'm going in the negative direction. So negative 225, right? We kind of ignore the negatives because it's really more of a distance in degree measure, right? We're going a distance. We're just going in a specific direction. That's where the negative comes from. So I still start at 0. And I know that 180 is 225 is between 180 and 270. So my angle is in here. And it's at 225 degrees. So if I look at this, my reference angle is, again, terminal side to the x-axis. And I'm looking for that angle. So if I think about where I started, I traveled 180 degrees plus some, right? 180 degrees plus, actually, my reference angle to get to 225. So how do I get from 180 to 225? Well, I travel another 45 degrees. It's the only way that would work. But just because your angle is negative doesn't really change anything. Our reference angle is always positive. Okay, so let's do some in radians. Now, again, I need my axis, so I'm going to label it here. I'm going in the negative direction, so I'm going to go negative pi over 2, negative 1 pi, negative 3 pi over 2, and negative 2 pi. And again, the negative really just means in that direction. So I'm traveling pi over 4. So what I like to do, what Mrs. Storvik taught me, is to turn these into decimals, right? Negative pi over 2 is like negative 0.5 pi, right? It's a half of pi. This is still 1. And then this is negative 1.5 pi. Because some of us are a little bit better looking at decimals instead of fractions, especially when there's pi involved. We get distracted. So if I'm looking at negative pi over 4, that's negative 0.25 pi, right? It's 1 pi over 4, and 1/4 is 0.25. So if I start at 0 and go to 0.5, I know that 0.25 is in between there, right? I know that a quarter is smaller than a half. So I'm going this way, negative pi over 4. And then I'm looking for the distance traveled. Well, this one seems easy, right? Because it's the same angle, except for what do we know about the reference angle? Think about it. What do we know? You're right. It's always positive. So it's actually positive pi over 4 because that's the distance I traveled. And I want to make something noticeable to you. I started with an angle with a denominator of 4, and my reference angle was pi over 4, which has the same denominator. So think about that for a second, and let's see what happens in number 4. Well, I'm still in radians, but now I'm in the positive direction, so I'm going to label my quadrantals in the positive direction. And this given angle is 5/3 pi, which is about 1.66 pi. So we need to think about where that goes. Remember, a half a pi is a half a pi, 0.5 pi. 1 pi, 1.5 pi. So where does 1.6 go? Remember that we start at 0, and now we're going in the positive direction. So there's 0.5, 1, 1.5. And then we get to 2. So at some point, you're like, no, stop. You passed 1.6. You're right. It's somewhere over here. This is 5 pi over 3. And I'm looking for my reference angle, my terminal side to my x-axis. The terminal side to my x-axis is going to be my reference angle theta prime. So again, we're thinking about this in terms of 1 revolution. If I made it almost to 360, but not quite. If I only went to 5 pi over 3, how many more do I need to go to get back to 2? Well, if we think about what 2 really is, it's 6 pi over 3. If I'm getting a common denominator between 2 pi over 1 and 5 pi over 3, I need to multiply top and bottom by 3. So how long is it going to take me to get to 5 pi over 3 to 6 pi over 3? Well, I hope you're thinking, well, duh, Miss Ernie, you just need 1 pi over 3 to travel the rest of that distance around the circle. And let's look at this again. I started with pi over 3, and my reference angle is pi over 3. Because we're cutting this circle into thirds. Okay? This half circle, we're cutting pi into thirds. Alright, before we keep going, I figured out how to fix this applet. So now that we've done a couple problems, let's look back at it. So in the first quadrant, my reference angle is the same as the given angle. And then when I get to the second quadrant, where my angles are between 90 and 180, my reference angle is the rest of the distance to get me to 180, right? I had 123. I have to go 56.2 more degrees to get to 180. Then I'm in the third quadrant, where I'm going a little past 180, right? How far past? Well, if I figure that out, I got to subtract 180 out, and I get to my reference angle. And then here it is in quadrant 4. But again, I really want to show you the negative angle. So if I start at 0, and I go negative, which this now looks like example 2, right? We went just negative a little bit. My reference angle is the same, except for it's positive, right? Same angle, but one's negative, one's positive. Keep going quadrant 3 technically, but I'm going through 2 in the negative direction. And keep going around, always the angle with the x-axis. So if you guys want to take a look at that, maybe especially while you're going to try one of these problems on your own, the website is right here at the top of your note sheet. So feel free to go for it. It probably won't work on your phones though, so you want to get to a computer because it's pretty awesome. Okay. So let me resituate here. And I would like you to try number 5 on your own, and that must be done when you come to class. I don't care if it's wrong. I just want you to give it your best shot. And I want to get you started on number 6. So I'm going 8 pi over 3, which is radians. So in positive direction, I'm just going to label my axis, which my quadrantals are always the same. And I need to think about what I've got going on here. Remember, pi over 2 is the same as 0.5 pi, 1 pi, 1.5 pi. Sometimes it just helps me figure out where this 8 pi over 3 is supposed to go. Well, 8 pi over 3 is 2.66 pi. So that means I need to travel 2.66 pi. Well, 1 pi, 2 pi is one way around, plus another 2/3, another 0.66. So that brings me all the way over here, right? Because 0.66, if I go 1 pi, that's one circle. Or 2 pi, I'm sorry. My 2 is 1 revolution. And then I have to travel 0.66. So the 0.66 is between 0.5 and 1. So that's how I know where I'm supposed to go. And I know this is 8 pi over 3. But if we look for as a coterminal, if I subtract 2 pi, this is also the same as 2 pi over 3, right? If I just look at this angle here, that's 2 pi over 3, right? 2/3 of the way to pi, 0.66 pi. So I need to know how long it's going to take me to get to the x-axis, right? Because that's my reference angle. So I want to just quickly do that. If I have 2/3 and I need to get to 1, which is 3/3, I need to get 1 more pi over 3. And again, I knew that so quickly because I started with pi over 3, so my reference angle has to be pi over 3. So again, you're going to try number 5, and you're going to do example 3, which I'm going to start for you, and it's really simple. We're labeling with degrees and radians, and in the first one, each mark represents 30, so like 30, 60, 90, 120. And I want you to give me radians like pi over 6 and pi over 3 and so on throughout the whole circle. And also with this one that goes by 45s, and you're going to give me radians like pi over 4 all the way around. So number 5 and example number 3. See you in class.